Hello students, this lecture is about thermal equilibrium. Our objectives will be to determine if heat flow will occur between two objects, and if it does, then determine the direction of heat flow between two objects, which way is thermal energy going to go, and finally to identify when two objects have reached what we're going to call thermal equilibrium. So let's start with a little bit of notes on thermal equilibrium. For starters, we need to define a condition called thermal contact. Now, the word contact usually means things are touching. If I'm in contact with somebody, they're sort of communicating or directly touching. So it's kind of the same way, except we're looking at it specifically from the perspective of thermal energy. So two objects are in thermal contact if thermal energy can flow between them. And that seems to be kind of a little bit of a circular definition, but it's going to become important later when we start talking about insulators and conductors of thermal energy. So basically, if we're allowing heat flow, if we're allowing thermal energy to move between two objects, we say that they're in thermal contact. Heat, if we recall from a previous lecture, heat is the flow or transfer of thermal energy. It's a process. It's the movement of thermal energy. Heat is going to occur between two objects if, and only if, one, the objects are in thermal contact. It has to be possible for heat flow to occur between those objects. If they're completely separated or separated by an insulator, or there's something else that is blocking thermal energy from flowing, well, then heat flow is not going to happen. The second condition is that the objects have to be at different temperatures. If we have two objects at the same temperature and I place them side by side, there's going to be no heat flow between them. There's no mechanism by which heat flow could occur. And we're going to look at, a little bit later on in the unit, we're going to zoom in on molecules and see why this is true, why these objects have to be at different temperatures for heat flow to happen between them. But for now, it's enough to say that we just need to have different temperatures of the objects if heat is going to flow. Both of these conditions have to be met for heat flow to happen. So now that we have defined how heat flow can occur, we can define something called thermal equilibrium. And if we look at the first part of this word, equal, it sounds kind of like equal or being the same, and that's not by accident. What's going to happen in thermal equilibrium is our temperatures are going to reach the same value. So heat is always going to flow from hot to cold. It doesn't go the other way. You go from the higher temperature object to the lower temperature object until both objects gradually reach the same temperature. Okay, nature kind of wants things to be balanced. Nature is always going to try and smooth out any differences between two places. We call it a gradient. And when we have two objects at different temperature, nature sees that and says, oh, those are at two different temperatures. I want to smooth that out and make them the same temperature. So we're going to move thermal energy from the hotter object to the cooler object until they sort of balance each other out. And that balancing condition, when they finally reach the same temperature, that's called thermal equilibrium. And the next point is a follow-on to that point. When objects have reached the same temperature, they are now in thermal equilibrium, and heat flow stops. So there's no more heat flow. And this kind of makes sense because before we said that objects have to be at different temperatures in order for heat flow to happen. So now if we've reached thermal equilibrium, by definition they're at the same temperature, so heat flow is just going to stop. No more heat flow. Okay? These are the two terms that we're going to be working with when we talk about thermal equilibrium. Here is just sort of a diagram that shows how heat is going to flow. You can see I have some hot water right next to some cold water, and we learned in a previous lecture that the hot water is at a higher temperature because molecules are moving faster. They're just jiggling around really fast. They have a high average kinetic energy. And over here is a pocket of cold water. And in the cold water, it's a lower temperature, which means the average kinetic energy is lower. So that means the molecules are moving slower. They're not moving as fast. They're still moving a little bit, just not as fast. And so this motion, if you can imagine these molecules bumping around, bumping around, bumping around, there's going to be more bumping from this side, from the left side, to the right side. So this bumping is going to transfer over here, and that's really what we're moving as heat flow. We're moving the kinetic energy of molecules from the hot water to the cooler water, and that results in heat flowing this way. We call this heat. Oops. Heat. Heat flows from hot to cold until they reach the same temperature. At some point in time in the future, these are going to reach the same temperature, probably something like warm or something between these two values. If I were to plot that on a graph, so this graph shows time on the x-axis and temperature on the y-axis in degrees Celsius. Here is my cold object starting at a chilly 5 degrees Celsius. That's maybe like ice water, and it's going to warm up gradually. Its temperature is going to increase, increase, increase. And by the way, heat is flowing between these objects. So these objects are in thermal contact. Heat flows from hotter object to the cooler object until they reach the same temperature. And that same temperature is right here. When they finally approach that value where they're equal, we're going to call that thermal equilibrium. And that's where it happens right there. So here's that cooler object gradually warming up, and it slowly reaches that temperature, and it stays there. The thermal equilibrium temperature for these two objects happens to be 30 degrees Celsius. It doesn't always have to be 30 degrees. Just in this case it is. It's sort of halfway between these two. Here's a hotter object that starts at a hot value of 70 degrees Celsius. It starts to cool down pretty quickly, and then it gets more gradual, more gradual, more gradual, and it finally cools down to that same temperature right there at the cooler value. So I've got, a hot object here, and I've got a cool object here. If they're in thermal contact, heat flow is going to happen between them until finally they reach the same temperature. And that's called thermal equilibrium. Okay, let's go back and check our objectives. Can you determine if heat flow is going to occur between two objects? So go back to our notes about what is necessary for heat flow to happen. Can you determine the direction of heat flow between two objects? Do you know, is it going to go from object A to object B or object B to object A? Which way is it going to flow? And you can tell by the temperature. And finally, can you identify when two objects have reached thermal equilibrium? How do you know they're in thermal equilibrium? You know when they've reached that final equal temperature at the very end.